Hello everyone, good afternoon, and welcome to our StaadPro online training program at SaiCad Center. And my name is Setu Nandania, and I am a Autodesk certified instructor. And let me continue our today's session with the StaadPro software. Actually, in our last session, in our last lecture, we are analyzing or we are designing one problem, right? So while designing, we face one error over there, but there is one problem that I won't get some time to reinstall this software. So we will discuss that designing problem in our next class, in our fifth date class, right? So today we are going to continue with the wind load and the earthquake one. No, Sarthak. If you are getting a single error in your analysis, that means you are wrong, right? Errors are not acceptable. Warning and notes are acceptable. Okay, no problem. We will discuss that designing problem again in our next class, right? And today we are going to discuss wind load and earthquake load. So how to assign wind and earthquake, right? So let me continue our new project. And also I'm going to show you our today's assignment. See, in our today's assignment, we have two problems we have. It is visible to you, this assignment 4.
No,
It is not visible. Okay,
yes, sir.
okay, good. So in our assignment here, I have given you two problems. See, this is problem number 1, and here we have a school building. So this is a plan view of a school building. We have to design it for G+8, right? And here we have to consider our wall load, sorry, wind load and seismic load also. So how do we do that? So for that we are going to create this model first. Then we have one residential building structure. So this problem I will show you how you can model it. Then analysis process you have to do in your homework, right? So let me begin with this school building design structure. So here we have a total 24.5 meter length, and 1 2 3 4 5 6 and 7 divisions we have. And similarly in the y direction we have 4.5, 1.56 and 10.5 meter we have, and 3 divisions will be there, right? And there is some misarrangement over here, so it is fine. And also I have show you one method by using our structure wizard, right, in our video. And so I'm not going to use that same method for the creation purpose. So let me do another one, right? So go to the StaadPro, go to the geometry, run structure wizard. We will use frame model. Length is 24.5 meter, height we will take for 1 meter, and width 10.5 meters. So here we consider total length, total width. Division in length 5, 7, then height 1, and in the width we have 3. We are considering equal division in this horizontal x direction, and in the z direction we have 4.5, then 1.5,
1.5.
then again 4.5, right? So these are the divisions we have, and click on apply, and this is our structure. Click on transfer, and yes, so actually we create this entire thing at a time. Now what I want to do, I want to move these columns to inward, right? How much? So let we calculate. Here we have to, here we want a 4 meter span, right? And we have actually 3.5. So 0.5 meter we have to translate it. So here just turn off this snap and grid, selecting these two, right click and click cut. Okay, yes, and again right click and click paste beam, and we want to go in positive x direction 0.5 meter. Okay, so this is done. We will do the same for these two. Again cut, okay, yes, and paste, but this time in negative x direction 0.5 meter, and that's it. But here we have a broken beams over here, so I'm going to delete these small pieces because we need to correct this thing. So select this both and delete it. Okay, and now with this add tool, add beam tool, we will add a new beam over here. And similarly over here we have staircase, so this beam is our mid span beam, right? So this beam is our mid span beam. Is there any option to join beams? Yes, we have. You will get that option from the geometry. Split beam we have, right? Then join beam is also there, but I generally don't prefer it. I just remove and create a new beam. And also we have inspect beam option over here. See, if by chance if you have some beams, overlapping beams, see here we have a tiny beam. I press Ctrl Z, and now I am creating one beam from here to here. So here we have a overlapping of the beams, right? So go to the geometry, go to the selected members, highlight. First we have to select, then go to the geometry and highlight tolerance 0 meter. Okay, so no two members are intersecting with each other. Actually we have one, so why? Okay, it is actually intersecting over here. Why it is not shown? Okay, we have to go to not highlight into, we have to go to the intersection. See, select your model again and go to the geometry, and here in intersect tolerance is 0. Sorry, we have to increase tolerance. That option might have some problem, but yes, we are also able to merge that beams. See, for example, you want to merge these both, so just select it, go to the geometry, and here we have merge selected member. So member number 48 and 49, click on merge and close. So in this way you can solve it also. So these are the options we have for the modeling, but I generally prefer to just delete it and create a newer one, so we do not have any kind of confusion over there. Okay, now this is our mid-span beam, so again cut it and right click and click on paste beam, and in the y direction minus 1.5 meter, hit OK. Right, so this beam is over here, and that's it for our first floor. Now we will do renumbering of node and renumbering of beam, because if you look at over here, so we have number of nodes 72 and total number of beams 95, right? And we actually delete many nodes and many beams over here and recreate many nodes, so we have to renumber this thing, because in our report these numbers will represent each and every members. That is why. So select your entire model, go to the geometry and go to the renumbering. First of all, we will renumber nodes. Okay, okay, we have to select nodes first. So take your nodal cursor and select node. Then go to the geometry, renumber nodes. Joint number, take it over here. Starting value, provide your starting value and click on accept. So we have total 68 nodes, right? And similarly for the beam, just select, go to the geometry,
Nine.
go to the renumber members, yes, and member number, take it over here. Starting from 1, click on accept, and there are 88 beams. So instead of 95, we have actually 88 beams over here or members over here.
Sir, please repeat this.
Is there any option to join beams like AutoCAD? Yes, that I have shown you. You can join with this join tool geometry, and here we have merge selected members. You can merge your member. Okay, we will use that option again in our next example, right?
Okay, ठीक है.
We have our residential structure design and we have a very complicated model. So we are actually going to model entire thing over here. So we will use that option at that time. So now we want G plus 8. So select this, go to the translation repeat, and here in the Y direction we want 8 copies at 3 meter spacing. Click on OK, and our model is ready now. Now, actually, we are going to discuss wind and earthquake both together, and also dead and live will be over here, right? So focus over here carefully. I am going. We don't know our problem is going to analyze properly or not, because I haven't reinstalled this software. But we will get that thing at the end when we are going to run this thing, right? But till I am going to show you the exact process, so focus over here. So go to the geometry, general, in the property, and first we have to define some cross section. So let we add point 35 by point 3 meter cross section with concrete material, right? I am choosing this one because nothing is given in our question, so we have to assume. So I'm going to assign this thing to the view, select, and yes. Now in the support, create fix support, add, and this support from the front view we will assign over here on the bottom, assign, and yes. And third step is our load and definition. Now break your vehicle, right? Just take a deep breath, and whatever complications we have is over here. So focus now. If you want to analyze earthquake in your model, right? So first you have to create a earthquake load cases over here. So don't create your dead load and live load case over here first. If you are going to create your dead load case and live load case, then you are going to add your earthquake load, then this software will always give you error, right? Because in the earthquake, in the case of earthquake, actually our load is transferring from bottom to top for the fraction of second. When earthquake occurs, for the fraction of second our load direction is reversed. Whatever load we have on negative y direction, that will be for in our positive y direction for the fraction of second, right, in the case of earthquake. So actually any analysis software calculates from load to support. In which direction calculation flows? From your load to support. So normally StaadPro analyze any model from top to bottom. He will start calculating each and everything from the top and keep continuing calculating and transferring that data up to the end. At the support we will get support reaction, right? But in the case of earthquake, our calculation starts from bottom, and then going to continue calculating up to the top. Then with our dead load, live load and other load, he is again calculating from top to bottom, and you will get the support reaction, right? So if by mistake you provide your dead load case first over here, or wind load case, or any other load case, so your our calculation will start from top to bottom, and at the end he will give us a error that seismic is not calculated, not able to solve, or not understable and something else, right? So first, if you are going to analyze your model with earthquake, so first task is define earthquake load. So it is clear now why we define our
Yes, sir.
earthquake load first. Good. So how to define our earthquake load? The next question. So as I told you, in the case of earthquake, for the fraction of second, our all the dead load and live load, all the types of load are change their direction. Instead of going bottom, it will go upward, right? Because earth is shaking. That's why. So in the earthquake, we have to take all the loads. Whatever loads you are going to provide in dead and live, you have to consider that all loads in positive direction. So first on the paper you have to calculate each and every load, whatever loads you are going to use in dead load case and live load case. So let me open one notepad over here, and we will create one note. Okay, here. And let me go on our problem, right? So first of all, we will create a list of dead load. So this is our dead load, and say first we have a wall load. So in our problem we have this 9-inch wall. See this 9-inch wall. So which are the 9-inch wall? So all the outer wall is 9-inch wall. So you all know how to calculate our wall load, right? So just open your calculator This calculator is visible.
Yes.
So 0.23 is our wall thickness, 9 inch, into 2.7 our wall height, into 20 our brick density. So 12.42 kilonewton per meter is our wall load. So in our dead load case, we will add minus 12.5 kilonewton per meter. This is our first dead load. Then second, we have 4.5 inch wall. That means half wall. So it will be half. So 12.5 divided by 2. So let me take 6.5. Okay, don't take 6.25. You can consider a little more. So kilonewton per meter. And then we have a parapet wall. So parapet wall we will consider as a 9-inch wall. So calculate 0.23 9-inch into 1 meter height into 20 density. So we have 4.5, right? 4.6. So let me take 4.5. So third one is parapet wall in the dead load case. So minus 4.5 kilonewton per meter. So these are our dead loads, and also fourth one, self weight. So we will consider
Self
this
weight.
much loads, right, in our dead load case. And now we have a list of live load case. So we will consider this floor load into live load case. So here see, we have a different areas with different loads. See, here we have a 6 kilonewton, right? What is this? Here we have 6 kilonewton, here we have 6 kilonewton, and here. These are the 6 kilonewton per meter square. Then over here we have 7 kilonewton per meter square, and on this area, this lobby area, we have 8 kilonewton per meter square. So these are our floor load. And initially in the earthquake load case, I will add all these things by myself. Then while we are going to apply the floor load, I will show you how we have calculated that, right? So you will get the exact idea. So actually what I will do, see, I'm going to explain you what I will do for this thing, because we are not able to assign this type of different floor loads, right? Because we haven't create floor. So what we will do, we will add 1 kilonewton per meter square in this area. In this area we will add 1 kilonewton per meter square, and in this area also. So in this both area we will add 1 kilonewton per meter square. Then over here we will add 2 kilonewton per meter square, right? And then at the end we will add 6 kilonewton to our entire model. So the total over here will be 7 kilonewton and total over here will be 8 kilonewton. Clear? Get my point? So in this way we will apply our dead loads and live loads. Sorry, in minus. So minus, minus, minus. Okay. And we will consider all these loads in positive direction in our earthquake, right? That's why we listed this thing over here. Now again, let me go to our StaadPro. Yes, save it. Okay. First of all, go to the definitions, and here we have to create a seismic definition. So click on seismic definition, click on add. You can add this from here also. See command loading definition and here seismic, right? So you can use any of them. Then choose your code. Actually, this is older version. Actually, we have 2015 revision also, but here we have 2005 revision. So IS 2000 to 2005 revision I am preferring, right? And here we have to enter zone, reduction factor, then other parameters we have to enter. But if you are confused with this thing, then please go to the generate. Click on the generate, and here he will ask us very simple question like which type of zone we have, zone factor. So it's a industrial zone or it's a city area, right? So that will be our zone. Now which type of city we have? Agra, Ahmedabad, so all the Indian cities we have over here. Let we choose any one. Then which type of our building structure is? So we have ordinary reinforcement frame structure we have, right? Then building factor of safety. So which type of building it is? If you choose important building, that means for example you have school or hospital and mall, so that type of building where people's our crowd is wider, right? So choose the important
Yes.
building, so your factor will be 1.5. If you choose general building, then your factor will be 1. So this is your our, you can say, our factor of safety, you can say. Then in other parameter, rock and soil type, which type of soil structure we have, let we consider medium. And structure type, it's a RCC structure, so take RC frame building, right? If you have steel structure, steel building, then choose steel structure. Damping ratio 0.05, because I have select series 5 version. If you have select series 6 or newer version, then type 5 only, because it will convert that value into percentage automatically. So damping ratio here 0.05. Click on generate and your data will be filled up over here. Check your damping ratio, it should be written 0.05 over here, right? If it is not, then change it. Then just click on add and close. So this is our earthquake definition, and in this definition we are going to add our all the loads that we are actually going to add as a dead load and live load, right? So now select this zone, click on add, and first of all self weight, what we will do, factor plus 1. Click on add. Then yes, anyone have question? Yes, we have that revision, but it is not updated in our older version. I have 2000 select series 5 StaadPro, that's why. Okay, Sarthak. Okay, here my screen is clear, it is visible.
Yes, sir.
Okay, good. So we are going to add all these loads that we listed in Notepad. See, let me try to set it side by side. Okay. Fine. So we add self weight. Now again click on your zone, click on add, and now we will add this wall load. So wall load is our member load. So click on member load, choose uniform. See, we have very limited option over here, right? Weight should be 12.5. So this is our 9-inch wall. Click on add, then 6.5. So this is our partition wall, 4.5-inch wall, and 4.5. This is for our parapet. So we add all these four loads. Now let we add our live load cases. So go to the floor weight. First of all, 1 kilonewton, and range over here I'm going to specify. We have total 9 floors, so 27 meters. So from 3 meter to 27 meter is our Y range. In X range from 0 to 10.5, and in Z range 4.5 to 6. I will explain you this thing when we will add live load, then you will get my point exactly, right? So don't worry about that, I'm just adding. Then again 1 kilonewton, 14 and 24.5 add, then 2 kilonewton in 10.5 to 14 and 0 to 6 add, then 6 kilonewton in entire model add, and close. Now see, self weight will automatically assign, this floor load will automatically assign. We have to assign only member weight, right? So for that, go to the top view, and here 9-inch, this 9-inch wall load. So I'm selecting this outer walls or beams. Okay, click on assign to selected beam, assign, and yes, but it will not visible for you, right? So just focus on your selection, that you are selecting everything properly. This is our 4.5-inch walls, partition walls. Okay, this one, assign to selected beams, assign, and yes, and parapet wall will be here, 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 and here. Assign and yes, right? So we actually define a definition over here. So clear up to this point how to define your definition, earthquake definition. Good. Now see, with the only definition we are not able to analyze our problem. We must have a load case for that. So for the earthquake we have to create 4 different load cases. See, focus on my word, we have to create 4 different load cases, because earthquake may come from positive x direction, it may come from negative x direction, it may come from positive z direction, and it may come from negative z direction. So we have 4 possibilities over here for the earthquake, right? But there are no chance that at a time you will get earthquake from 2 direction, right? So we have to consider each and every load case separately, so it will calculate separately. So now you have to create 4 load cases over here. So click on load case detail, click on add, and primary load case, Loading type, choose seismic over here. It will be helpful for our future work. So now you have to provide your loading type also, right? That which type of load case is this. So this is my seismic load case, and I'm giving a name, earthquake in X positive. Select it, copy, and add one more, X negative, Z
Z,
positive,
Z negative.
and Z negative, right? See, again I'm repeating, you have to create 4 individual load cases. Don't put your all the loads in single load case. Okay, otherwise it will consider as you are getting a earthquake load from all 4 direction at a time, and this is not possible, right? So you have to create 4 individual load cases. Now in the load case 1, in the X positive, click on add, go to the seismic load, and here we just have to provide the direction. So X direction factor 1, click on add and close. So this load, whatever load we have defined in our definition, is now applied from the positive X direction. Similarly, for the X negative, click on add, go to the seismic X direction, but factor will be -1,
Fine.
add and close, right? So whatever load we have defined in our definition is now added in this load case. Same for the Z positive, seismic Z factor +1, add close, and Z negative, add factor, okay, seismic Z direction and -1, add and close. So that's it. We done about earthquake loading. After you finish up to this point, now you are able to add your dead load case, then live load case, right? So now click on the load case, click on the add and choose dead over here, name it dead, click on add and one more live load, click on add and close. So now you will get the idea about all this load that we have added over here, because it will be visible when we apply from here, right? So first of all, we will add all the loads. So click on dead load case, add self weight factor -1, add member load -12.5, add -6.5, add and -4.5, add. So we add 4 loads in our dead load case. Self weight assigned to view, then this wall load, so that will be on the from the top, 9-inch wall, like this. See, if you view it from isometric view, we have selected all the boundary walls, right? So click on the 9-inch wall load and click on assign, and yes, so we assign 9-inch wall load. Again from the top view, the next one, partition wall. So these all are our partition walls. Okay, click on assign, yes, yes, and the rest parapet wall. So we have 4 places for the parapet wall. Done. Now our live load. So what we have done, we will add 1 kilonewton per meter square in this area. See over here. So how to we add? I'm going to teach you over here. See, 1 kilonewton we will add only on this area. Our y range is fixed. We have from 3 meter to 27 meter, right? So this is our y range, but we have our x range and z range also. So this is our x and this is our z. This one is our origin point, this point, right? So we want to add our 1 kilonewton per meter square floor load only on this area, this much area. So what is our x range? X will start from 0 to 10.5, 3.5, 3.5, 3.5, 10.5. Similarly, Z will start from 4.5 to 6, right? So this area will be enclosed. You will get the my point when I apply. See, click on live load case, add floor load minus 1 kilonewton. Y range is fixed from 3 to 27. X range is 0 to 10.5 and Z range is 4.5 to 6. Click on add and close. Now see, we apply 1 kilonewton per meter square floor load only on this area, right? Got it or any confusion for this thing? Let me do it again. Same thing.
इसको काय काय
The,
मराठीत सांगतो
hello?
नाही का
Yes.
हा
Let me do it again. So this time our Z range is fixed.
शेत
Z, Z range is from here to here. So Z range will be remain as it is 4.5 to 6. But our X range is now from here to here, right? So this is 3.5, 3.5, 3.5 and 3.5. So total 14 over here up to 24. So my X range is now 14 to 24 meter. Uh, Sarthak, we will discuss that later. First, we are applying this floor load, right? So again, load case, add floor load minus 1, y range from 3 meter to 27, x range is now 14 to 24.5 and z range is fixed 4.5 to 6. Click on add and close. Now see, this one is over here 1 kilonewton. Similarly, we have to add 2 kilonewton on this area. So x range will be from 10.5 to 14 and z range will be 0 to 6 from here to here, right? So with the coordinates, yeah, just we have to work. We have to enclose this area, so we have to work with coordinates. From x we have to go to here and in z from here to here. So again click on add floor load minus 2 from 3 to 27, 10.5 to 14 and 0 to 6. Add and close. So this is our 2 kilonewton floor load. Now at the end we will apply 6 kilonewton to entire model. So over here total will be 7 and over here total will be 8, right? So our requirement will be fulfilled. So add floor load and minus 6 kilonewton per meter square from 3 meter to 27. That's it. X is infinite, Z is infinite. Add and close. So we get everything over here. Now we have one question from Sarthak that can we create plate and then apply floor load on respective plates? Yes, we can. If you are going to create a plate, then your load will be plate load, not floor load, right? Whatever floor load is given over here, that you can apply in that area where your floor is not exist. If you create any object over there, then you have to apply a plate load at that point. In our next class we will discuss our water tank problem. That water tank we will create with the plates and we will apply plate load over there, so you will get the idea about shear wall concept, right? Okay, so yes, in the loadings our task 1 earthquake is done. Task number 2 dead load and live load is also done, right? Now our third task, wind load. So for the wind load, we have to calculate our PZ, pressure intensity value, right? And for that we have our Indian code IS, which one? 875 part 3, right?
Division second.
Hmm? Yes. So in that code we have equation for PZ equal to 0.6 into VZ into VZ, right? So that
Yes.
equation we have where Vz is designed wind velocity and other Vz we
Good.
have to take it from code, right? And Vz is equal to Vb
Yeah.
into K1 into K2 into K3. So this K1, K2, K3, all these three things are just multiplication factor,
Coefficient.
right? Constants
Coefficient.
that we have to take from
Constant.
the table. So ultimately we want a value of PZ. To add a wind load in this StaadPro software, you have to calculate or you have to find out your PZ value and also height. So here I am just considering my PZ is equal to 1.5 kilonewton per meter square, right? Up to 30 meter height, because our building have 27-meter height, so we are taking 30 up to 30-meter height, right? So I am just considering this PZ value over here, pressure intensity. So now we are going to add our wind load. So for that first we have to create our wind definition. So click on the wind definition, click on add, and here name it. Wind 1 is fine. Okay, now select your wind, click on add, and here you have to provide your intensity that we discussed, PZ value, right? So let me add 1.5 up to 30 meter height. For this problem I am considering a direct 30 meter height, But if you want to provide in detail, that you can use 0.8 up to maybe 5 meter, right? And then 0.86 up to 10 meter. Then we have 1 up to 15 meter, then 1.24 up to 20 meter, and then 1.35 up to 25 meter, then 1.5 up to 30 meter. So in this way you are also able to provide your pressure intensity in the intervals, right? You can choose 1 meter interval also. So that depends on your calculation, or what the practical data you have, what the code data you have, and in this way you have to fill your pressure intensity in the table, right? Then just click on the add and exposure factor, type 1 over here and click on add. Now this exposure we need to assign to our model. Focus over here. This exposure we need to assign to our model. So select it, click on assign to view, and what will happen? It will examine our model with this exposure. See, he find out all the nodes that which type of model geometry we have, right? Now the pressure intensity we have provided. Now we have to provide loads. So to convert your definition into load, what we have to do? We have to create our load case, right? And again, we have to create 4 different load case for the wind also, because wind may come from all 4 direction, right? But it will not come from 2 direction at a time. It is not possible, right? So we have to create 4 individual load cases. So click on the load case detail, add, and change your loading type to wind now, and type wind load in x positive, add, then x negative, add, z positive, z negative. So here we have 4 different wind loads, wind load cases. Now just we have to provide the direction, whatever wind intensity we have, provide the direction. So click on the wind x1, click on add, go to the wind load, and here we have wind in x and wind in z. So click on the x, type your factor over here, your wind factor. Let me take our factor 0.8, because 20% air is there which is going to escape, right? So only 80% air is creating pressure on my model. But we have 2 things over here, windward and leeward. So what is this windward and leeward? Just a minute. I haven't used that option yet. Where is that calculate from code? Calculate as per ASCE 7. We do not have our Indian code over here. This is foreign code. This is not our code. We do not have that facility that it will automatically calculate as per IS code. This is not our IS code, so don't use that. Okay. So it will calculate as per ASCE7. This is not our Indian 875 part 3 code, right? So we have to provide our intensity manually. Delete. So what we are discussing about two things. See, from the x positive. So which one is our positive x? So this direction is our positive x. So we have mainly two phases. Whenever air is blowing from this direction, we have this phase who is going to face that wind force, right? This area is going to face that wind force. So this phase is known as windward phase, a phase in the direction of wind. And the opposite phase of your structure is known as leeward phase, which is actually going to feel that drag force over there, right? So mainly two forces we have in the case of wind. If you have analyzed your model in a wind turbine, or if you have some idea about the CFD, computational fluid dynamics, then you have a knowledge about drag force. So when a wind strike on this face, right, on this face, so this is our windward phase, so it will create some pressure on this face, and on the other side it will be low pressure zone, so it will create some kind of vacuum on the other side. So we have again pressurized effect from the inward side on the back face also, due to
Indeed.
that drag force, right? So whatever, so in the short, you have to understand only that thing. Whatever phase is in the front of the wind is known as windward phase, and whatever phase on the back side of the wind is known as leeward phase. And both the phase experiencing some types of wind pressure. This one is experiencing positive one, this one experience negative one. So again, click on the X positive, add wind load X windward phase factor 0.8. So 80% air is creating load. Don't provide any range over here. Just click on add and close. So now see, this is our wind pressure, right? Similarly, again click on add and choose wind load, but this time X leeward. And here we will experience very less air pressure due to that drag force. So choose your factor 0.5 or 0.4, click on add and close. So this is your leeward, this is windward, this is leeward, right? So both the phase will experience some kind of pressure. Similarly, we have to provide in all the directions. So X negative, click on add, wind load X positive, sorry, X negative, right? So factor minus 0.8, add, and in the leeward factor will be minus 0.5, add and close. So see, these loads we have. If you view it from the front view, you will see that intensity that we have provided is actually increasing as we go up, right? So that's why this arrow length is increasing. So we have apply a correct value in a correct sequence. Now for the Z positive and Z negative, click on add, wind load Z positive 0.8, add, and leeward 0.5, add and close. And for the Z negative, add wind Z minus 0.8, add and leeward minus 0.5, add and close. Right, view it from the front and turn on your load value. Go to the right click, go to the structure diagram or labels, sorry, in the labels, turn on this load value, or shift V we have, shift V. So your load value will be over here. Actually, just let me delete one. Let me delete this leeward. So we are able to read this value. See, the wind pressure over here is low, 6.3, then 6.7, then 7.6. See, increasing as we go up because our intensity is increased. And from here it is actually decreased. See, 6.7. Why? Because now air have space to escape. So on this phase we have a low pressure compared to here. So in this way our wind load distribution is there. Let me add our leeward back. Wind leeward Z minus 0.5, add and close. So it is clear now how to add earthquake load, how to add wind load, and how to add dead load and live load. Good. Just a minute. Okay. So before we continue our next process, I hope you all are over here or just gone by putting your computer on lecture. Are you in front of your screen or not?
Visible.
Okay, then it is fine. Now let me check that our problem actually runs or not. Then we will continue. Oh, hope so. We do not have error due to any kind of thing. So click on the command analyze, perform, and analyze and run. Okay, see, here we have one warning and two notes, and this thing is fine. But if you have any kind of error, that means something wrong. Your answer is not, or your solution is not converged, right? So just up to this point, we have done each and everything properly and correctly. This thing proves that, right? We will see our result at the end. Our next task is to create a combination load cases, because as per the code we have to create some combinations. So which are they? So code give us seven different equations for the dead load, equations for the live load, equations for the wind and equations for this earthquake. So our first equation,
Oh.
combinations, right? And first equation we have, what if suppose 1.5 times our dead load and live load will be. So this is our first equation. Then three equations for the wind. So suppose 1.5 times our dead load plus wind load. So what will happen when a dead load and wind load increases 1.5 times? And third equation we have, what if 1.2 times dead load plus live load plus wind load.
Plus Windward.
Yes, you are right. And the fourth equation is
One earthquake plus
zero point
wind
0.9 times dead load plus wind load. Suppose this loading condition
earthquake.
decreases due to some reason. So what will happen? That also we need to check. So these are the three equations for the wind. Then fifth one,
Okay.
1.5 times dead load plus earthquake. Then sixth, 1.2 times dead live and earthquake. And seventh, 0 0.9 times dead and earthquake,
Dead load.
right? So these three equation is for the earthquake, these three equations is combination of wind, and this is for the dead and live. So these are the three equations we have. Seven equations, right? So how many combination will be there due to this equation? So we have only one dead load case and one live load case, right? So we will get only one combination over here. We have one dead load case but four wind load case. So we have our four load combinations. 1.5 times dead load plus wind load x positive, 1.5 times dead load plus wind load x negative, then z positive, then z negative. So that type of four combination load we are able to create right now. Similarly, over here we will also get four combination load cases, right? This is equation, but we have multiple load cases. Are you getting me?
Yes.
So over here we will also get four combinations, then four combinations in earthquake. Okay, so the total combination over here is, add this all,
25.
25, right? So here we have to
Yes.
add 25 combination load cases. And if you want to add that thing manually, and that you can, like this, just go to the load case, click on add, and go to the load combination, provide a name, then your 1.5 times whatever, then click this dead load, this live load. So this is our first load case, then similarly second, third, fourth. So in this way we have to add total 25 load combination load cases, right? And see, as per the code we do not have a single load case for the wind and earthquake together. Why? Is there any reason behind this thing? Why we do not have a wind and earthquake together? Anyone have answer? Okay, let me tell you. Till current date, this 2020, right? We experience this corona effect, but we never experience a storm and a earthquake together. Understood? Up to the current date, we have never experienced this thing together yet, right? We never experience a windstorm and a earthquake at a time. That's why we have do not have to check that type of equation. So that code is not telling us to check earthquake and wind together. That is why. Yes. So now let me add this combination equations by some equation rules. So I'm going to show you how to add all these things together. So go to the command, go to the loading, and here we have auto load combination rules. Auto load rule. Command loading auto load rule. Okay. Go to the auto load rule table. Here choose our Indian code and create a new category. Choose our Indian code and create a new category, and category name you can provide yourself. Let's have earthquake and wind load. So this is my category name. And number of rules, how many equations you want. So these are the equations. How many we have? 1 2 3 4 5 6 and 7 equations. So write 7 over here. If you are just analyzing wind only, then you have to write 4 equations because you have 4, right? If you are just analyzing earthquake, then still you have 4. One is for the dead and live and 3 will be with earthquake, right? But if you have both, then total will be 7. Click on OK and you will get new table with 7 row. Here we have dead, live, wind and seismic columns, right? So just add your factors over here. That first equation is 1.5 in dead and 1.5 in live. So this is my first equation. Then same for the second, 1.5 dead and 1.5 wind. Then 1.2 dead, 1.2 live and 1.2 wind. Then 0.9 dead and 0.9 wind. 1.5 dead and 1.5 seismic, 1.2 dead, 1.2 live and 1.2 seismic, 0.9 dead and 0.9 seismic. At the end, when you complete this task, just click on update table, and if you get these white cells properly, then it is fine. You have nothing done wrong, right? So our next question is how the state software will get the idea that which one is the dead load case and which one is the live load case, right? So that's due to when we are creating this load case, we add a loading type over there. So that loading type will help us now over here. That's why we have that loading type, right? Otherwise that thing doesn't matter. Whatever things you have dead load case or live load case, so that doesn't matter. For the StaadPro, it's just a load, nothing else, right? For us it is a dead load case and live load case. For the StaadPro, it's just a load. So whenever you are creating this load case, provide your loading type, then and then this thing will work. Okay, so here we have updated our table and our name is EQ and WL. Close this table. Now again go to the load case detail, click on add and go to the auto load combination. Choose your code and choose your table, then click on generate load. So it will create that much load. See, 25 load cases we have, right, as per our calculation. Now click on add and close. So these are the our combination load cases. So total load cases are 35 over here. 10 is our primary and the 25 our combination. So total we have 35. Again analyze your study. You will get a updated result. Now go to the post process and check your results. See, this displacement is due to earthquake in Z positive, earthquake in X positive, negative, Z positive, negative, dead load, live load, wind X positive, negative, and the other combinations. Right, so this is our analysis result. Now if you want to design, then again go to the modeling, go to the design data and choose as 456, provide strength of concrete, then strength of steel, and a track, assign to view, assign to view, assign to view, and design of beam, design of column, and takeoff. Design of beam, select parallel to X, select parallel to Z, assign yes, and design of column, select parallel to Y, assign yes, and again analyze your study. So we have so many warnings over here, and actually our problem is going to run, see, with the same process. So yesterday we are having some problems, but today we get the result actually, right? So here we have 180 warnings. That means there are 180 members are there who is actually going to fail in the study, in the calculation. So for that, I'm
Mm.
creating a new column size in my structure because we have a very huge axial load. So go to the general, click on define rectangular shape of 0.2 feet by 2 feet. So 6 meter by zero point 0.6 meter. The concrete material, add and close, and this should be select parallel to Y. All the columns should be bigger. Again run the study. Still we have 62 warnings. That means there are 62 members is there who is failed in the reinforcement process, right? Click on done, and now just double click on your column and you will get over here a concrete design. So he is suggesting us that we should use a 12 diameter member and number of members 36 in this column, right? So this is the steel requirement, and the percentage of steel over here is 1.13. That means for example we want 2 to 3% percentage of steel, then we can reduce the size of this column because we are having a less percentage of steel. For this we are having a concrete design for this also. So if for any member if you don't find this concrete design option, that means that member is actually going to fail. So we are having 2% steel over here at the center. See, 16 diameter, 36 member. So that is our reinforcement detail, but we will yes, 1.13 is economical, but that depends on the client requirement. Okay, so in this way you have to analyze your model first and then calculate it, right? Then assign combinations, then go for the reinforcement detail. We will discuss this reinforcement detail or analysis problem in our next class, in our day 5th class again, right? And also you have one more example. See this one, and there is one dimension missing over here, this one. So this you should take 2.25 meter. Okay, 2.25 meter. 2.35 meter. Okay, just take it 2.35 meter. So it will be fine for you to model this thing, or should I model it for you? Hello, shall I model this thing for you? This four session I learned more than YouTube lectures. YouTube lectures are misguiding. They just assigning load. Thanks a lot, sir, guiding a knowledge. That's a reason, dear, that why people are not preferring or not believing on the YouTube only. Because there are many things. See, whatever I'm doing over here is live in front of you, right? And whatever you are viewing on YouTube is not a live thing. If he gets some kind of error or some kind of things, he will cut that portion, right? So that's a entire different thing. You can ask me a question, like that's the difference actually. That you learn from the recorded video and you learn from the lecturer. No, it is not hard. Niranjan, it is not hard. Just practice it once yourself. Everything will be clear. No, we do not have staircases. We have to model it manually in the StaadPro. We do not have that staircases and that type of thing. So if you want a staircase, you have to model it yourself manually. So just try to model this building, and in the guideline what is there, you have to model it for the G plus 15, right? So it's a 15-story building. Good. So in our next class we will discuss about the reinforcement detail, how to check this reinforcement. Okay, I will again check it that what's the problem in our last session, that we are getting that error due to what reason. I will see. Okay, I don't have actually latest version, so I don't know about that. So you just try that option for yourself. If you have that inbuilt in your latest version, then okay, students. So see you on our next class, and it we have on Thursday, right? So Thursday will be our last class, and we will see moving load and also water tank analysis in our last class. Okay, so thank you friends, and see you on Thursday. And just also share your comments and thoughts on other social medias. It will be helpful for me and for my team also, right? You can mention trainer's name also over there, that my name, and also whatever things you like, you dislike, and everything. My LinkedIn profile name is same, Setu Nandania, right? So see you on Thursday. Bye.